Hello everyone, and thank you for joining me in this masterclass where we learn about Model Context Protocol, the buzzword that is going all around the internet for the last, 7 or 8 months. We're going to demystify this concept. This was an amazing thing that was developed by Anthropic last year in 2024, and I believe that that is one of the technologies or one of the concepts for the reason of why people are saying that 2025 is going to be the years of agent. But with every invention, if I take, for example, MCP as an invention, there are multiple discoveries that are going to happen, and we all are going to make these discoveries. But it is important to understand why this invention was needed, right? Because that why drives the use cases that we can think of creatively to use this technology, which is true for blockchain as well. The cryptocurrencies kind of come up because people understood the why of blockchains, and we're going to do that. So in this series of talk, we are going to cover multiple modules, and we are going to talk right from the beginning of the origin story of Model Context Protocol, why it came up. We'll do some coding in between in some modules. We'll build our own MCPs. We'll try to explain what MCPs are, some of the advanced concepts. And later we're going to talk about how to use this securely. What are the things that you need to keep in mind when you talk about security of Model Context Protocol, right? With me. So with this, let us go ahead and figure out. Let me just go ahead and go to the slideshow. Great, that looks good. So we're going to talk about Model Context Protocol. And you'd have probably heard about this terminology, right? That USB-C for AI, and why it is the USB-C of AI. I'm not going to discuss about this right now, and I want you to unfold this yourself. But keep in mind that when you connect the USB-C of your laptop or your computer, when you connect an external device to your computer, whether it is a microphone, whether it is a video device, whether it's a hard drive, you don't have to specifically tell your computer that this is what it is, right? So I want you to unfold as we go ahead and talk about that, how this analogy actually works. So keep in mind that you still, with every slide or with every explanation, question yourself, in my opinion, that why this analogy fits in. And I'm pretty sure I don't have to explain about it. You will get it yourself, right? So before that, this is me. I'm 𝐉𝐚𝐲𝐝 𝐶𝐞𝐞𝐩. You can call me JD, and I'm the director of AI and tech for Piramal Finance, a global tech influencer. I'm co-authoring a book with my co-author Harini Muralinath, who is also a business security officer of ThoughtWorks. It's called Value Vector. It's going to come up. And I'm part of OpenAI's red team. So one of my job is to basically break their models before they come up in something like a ChatGPT or something like that. Here's my LinkedIn. I'll love to stay connected. Love to answer your questions if you have any. But having said that, what we are going to cover in this module. So we are going to cover about origins of MCP, right? And we'll go in details about these in a moment. Before MCP, we'll also learn about context, why context is important for a large language model, right? Slowly, if you see, as I was saying, we're going to the why part of it. And before Model Context Protocol, companies like OpenAI basically came up with an approach. They understood the need, right? There are some ways to basically provide dynamic context to the large language models. And then we'll slowly figure out why, even after that, Model Context Protocol, an approach or a framework or a protocol like Model Context Protocol was needed. And then we'll look at how does it work, right? A high-level architecture and overview of that. So, the world of context. Now, if you remember when ChatGPT came, if you have used this in the early stages in November 2022, you know that it is all about context. So if you could have gone to ChatGPT and asked a question that, hey, create an itinerary for me for Goa that I'm going to travel. And you know that a tool like ChatGPT or Gemini will probably not say no in most of the cases to you. It will go ahead and create an itinerary for you, but you are almost sure that it does not work because it does not know you. you had to provide more and more context from your perspective to this LLM, right? And based on that, what I'm going to talk about right now is what is this context and why it is important for any large language models or any generative AI models for you to provide. Let's say you want to create an image. If you don't explain the image, for example, the right side image that you see of Garfield, and you'll probably come to know why Garfield here in the next slide. It was created by AI, right? And to create that, the prompt, remember, not prompt engineering. I don't like the word prompt engineering. It's prompting. Prompt engineering is a subject in data science. It's a huge thing. But what we want to figure out that how do we talk to these AIs, providing more and more context. So to understand this concept, I went to ChatGPT and I thought, let's talk to it to figure out if I can come up with some examples. And that is why the word Garfield or the image Garfield that you saw. So I went and asked, can cats talk? It said no. But then I said, I meant Garfield the cat. And that's when it says yes. So Garfield here is the concept. And without that, I was getting a generic answer whether cats can talk or not. But only when I brought my context in, that's when I started getting more specific answer that what I need. Let's look at some more examples, right? And in next slides, let's look at how does ChatGPT behave when I ask you to complete a sentence, right? So ChatGPT should know sky is blue, and that is what I wanted to say, that sky is blue. And we can go to ChatGPT and say that complete the sky is, and then hit enter. Give it a moment to understand what it might have given as a response. You can pause and think about it a little bit, but for now, let me go ahead. The response that ChatGPT gave me is the sky is a vast expanse of ours that takes on different colors and appearances depending on the time of the day and blah, 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 right? So if you see here, it is being creative because the job of these models are being to be creative, which is absolutely right. But what I wanted to say is sky is blue. So maybe as a user, I think, okay, what if I ask it not to create a paragraph and I ask it to create a sentence? Maybe it will start understanding what I'm looking for. So I went ahead and said that, okay, don't write paragraph, complete the sentence. So now I'm saying that, okay, you have to restrict your length, right? So the sky is, and you hit enter. And the response that I get, the sky is beautiful, ever-changing canvas that captivates and inspires us with its merit of colors and patterns. Still not what I'm looking for. And then only when I go ahead and be absolutely specific, that complete the sentence with property of color in mind, this is when it says the sky is blue. So what we understand out of it, we understand that if you ask it generic questions, it's going to give you a generic answer. If you become more and more specific by putting more and more context to your questions, one or the other front, then you'll start seeing the response that you can really utilize in your use case or whatever you're working on. And it is true for any generative AI application, right? So you can use it for LLMs where ChatGPT, Gemini, Claude are there. You can use it for image generation where you can explain what you're looking for. Even image, when you try to generate an image, you can go and say that, hey, create an image of a lion, right? Sitting in a jungle. But you can also go and say that, create an image of a lion taken with a Canon 5D Mark III with 24 to 70 mm 70 mm lens. The lit, it's well lit where we have external lights and we are also utilizing the lights that's coming from the sun and everything. So that's how you provide context, and this is where the fun begins, and this is where you get to see why LLM's context is important, right? And before we go to the origin story of this, I wanted to mention that the context can come dynamically in your programming, so you can program your applications while you're writing, or you can basically go ahead and have a dynamic discovery of this, and this is where the MCP comes in, so we'll go into that later. Looking at the origin story, to be you know, 1.5 years back, OpenAI actually came up with something called function calls. So when we started looking at certain things like using the APIs, using the API key, when we started building our own applications, they included this function call key, where you can pass the function that you have written and the arguments that the function needs. Or it can be an API call as well. So they understood the need, right? So now, if you figure out that I'm trying to create a weather application where, as a user, it's a chatbot application where you can go and ask about the weather of London. What is the current weather of London? If you go to ChatGPT without function calling at that point of time, it will say that, sorry, I don't have that data because we are now using the model as solo. But with this, we can actually create a program where we use the function call and say that whenever the question to LLM comes, hey LLM, you have something at your disposal to use to get the current context or to make sure that you get the right answers, right? So that time the flow becomes like this. So you ask a question, the LLM understands your question and figures out, okay, I need to get the weather of London. And then it finds that, hey, I also have a function call, which is the get weather, given to me, and you can give as many function calls as you want for different tasks to the same LLMs, right? And then it figures out that, okay, the argument that it needs is a city, which is London, and then it invokes this get weather application. The get weather application just executes. There is no AI behind it. It's just a function call, and it returns a JSON with the current weather to the LLM, and then LLM looks at this JSON and creates an answer the way you want it to be, right? So if you look at it, it's also getting context from the get weather thing, right? And from that perspective, if you look at it, this is the birth where we started looking at LLMs being autonomous. So LLMs are brains, and we thought that with the brain, a human can probably think, but you need to get more actions done with your hands, with your eyes, with your ears, with your nose to feed more data to brain, where it can get more and more specific responses. In the same way, we thought if we can give LLMs some set of tools, right, where it can use it in an autonomous way, whenever the question is asked, regardless of the user providing those information, things would just be amazing, and they were, right? So we extended the capabilities of LLMs to perform real-world actions through these function calls, right? And we started seeing that it has started to become more useful for us. But there was a problem at that point of time. We actually did use these things for a long period of time. When I say long in the world of generative AI, long means 7-8 months is a pretty long time. People started using it. So instead of function calling, they started giving out more and more functions. Like, for example, they started using Gmail APIs, calendar APIs, or something like a Google search, a research kind of thing to their applications, which was awesome. But there was one specific problem. And that problem is solved by MCP. Let's discuss about that problem now. So when organizations actually started using this thing a lot, because as I was saying, this actually gave them a lot of varieties of use cases that got just unfolded, right? People started using, giving access to file systems, they had their internal APIs, and many more. Soon we realized that the classic N into M problem, or the scenario, kind of making the complex integrations, and it becomes more complex with a larger set of integrations as well, right? So to give an example, let's say you have 3 LLMs. So your organizations have kind of adopted AI, and you have running multiple use cases, and you have 3 large language models you use for 3 different purposes. And that's true, because every large language model can't do all the work the way you want it to be. For example, in my opinion, Claude does a very good job of writing codes. If you try to write codes using OpenAI models, it doesn't matter if you're using the larger models of OpenAI, it might not do the same critical thinking when it comes to writing codes, right? So let's say they have this thing, and they have multiple tools for which they have created this integration where they have built multiple chat applications, and they have Salesforce CRM, They have Jira tracking. There's some inventory API. There's a different inventory API for different things that they have been working on. And these are all working fine. But if you see here, the number of custom integration that was done is equal to 12. And it's just a small example. Usually you'll have many more tools or many more APIs or many more function in that sense that you want your AI systems to talk to, right? This is problem number one. So you have to write a lot of redundant code just by changing probably the API route and everything. Speaking of API route, what if the API route gets changed? You have to again come back as a developer and then fix that route in your code base as well, right? Let's take the example of Jira itself. Jira has many APIs. You have update tickets, put a comment, get details of Jira or a story, etc., right? And you provide all these functions to your let's say Jira chatbot that you have created for your teams. Tomorrow you say that, hey, Jira, maybe it has started to become a little bit costly for my company. I want to go to something else, right? Guess what? You have to come back, and as a developer, you go through nightmares to basically making that change happen, right? So your development cost and the maintenance has become a lot bigger, right? And again, your system become brittle. For example, let's say you have another inventory API that you have built in-house that basically gives you the details of your inventories, right? And suddenly that API path got changed, as I was saying before, right? So the route got changed. Your chatbot starts failing, right? And that is the classic N into M scenarios. In my experience, I have seen this N into M equal to X, where X has gone to 120, 125. I have seen that. So that is restricting organizations to basically go ahead and make something like a robust integration of AI into the organization. And your maintainability, your scalability started to become a challenge, right? And this is where Anthropic came up with the Model Context Protocol. Now, Model Context Protocol is a way basically to let your client, it's a client-server model at the end of the day, and we'll go a little deeper into that. But here we are saying that if you build an AI application and you have a server, you don't have to worry about if the server is changed. To give an example, typically a model server MCP or a model server model context protocol has something called host. And this host will have an MCP client. And now you can think of MCP client here. If you have been into the prompt to code or vibe coding recently, then these are your IDs, right? So that's a client where you have a large language model running, or an application that is built with large language model running. Or it can be a chatbot. So if you have Claude desktop and you have, let's say, Claude's upgraded membership, then you can add MCPs to that as well. So that is your MCP client, right? Now this MCP client can be connected to multiple MCP servers. So here, for example, you have server A, server B, server C, and each of these servers can have one or multiple tools with which it is connected to. For example, here in your MCP server A is connected to a local data source that you have. It can be your file system. It can be something that is running in your local box. MCP B can be an email server capabilities, right? So let's say you have connected to your Gmail, where it can create an email, it can send an email, it can see your mailbox, etc. There are different tools that this server B kind of takes care of. And the server C is maybe some other remote service that you have that you're calling. Let's say for the discussion's sake, it's a weather API that it has got access to, right? Now, what happens here is that the MCP host has the capability to ask the MCP servers, hey, what do you have? I've got this thing that I have to do from my user, and user being me and you, who have asked the MCP host or client to do certain things. Let's say you're chatting and you say that, hey, I have received an invoice for my purchase of clothes in my email. Can you go ahead and figure out how much was the invoice for, right? Now, after this question, it goes to something like an MCP server tries to figure out all the MCP servers to which it is exposed to, which one has the capabilities to read emails, and it figures out that, hey, server B has this, right? And server B kind of goes ahead and gives the capabilities to the large language model, in this case, which is the MCP client, to basically run some queries based on what it is asking for, right? And you basically, when you connect this MCP server B, you provide your authentication to your Gmail as well, so that on demand LLMs can basically figure it out. So what it has done, it has basically made sure that there's a simplified integration that connects to LLM tools are now easy. And I want you to go back to the first slide that I was talking, the USB Type-C examples. You can start thinking about in that way. The modularity and the scalability, like swapping the component is now easy. Like for example, let's say this server C was the Jira MCP that we created, or the Atlassian MCP, and tomorrow I want to just move to something else. Then all I have to do is just move to server D, which is my new project management tool that I have onboarded if they provide APIs to me, and that's done. I don't have to go ahead and change any codes out here, and it makes the development a lot faster than you expect, right? So let me give you an example. So if I go to ChatGPT, right? So this one. So I asked it a question that what are the recent board games that I bought? And it says that I don't have access to your recent purchases unless you have shared that info with me earlier, right? Now, today is 27th of July, and ChatGPT released agents. So if you see here, if you click here, you'll get to see there are agents. I think you'll get to see when you create a new chat. So there's an agent mode, right? And this agent mode, using that, you can actually connect to your Gmails, which is through MCPs again, right? And I did that. The reason I actually did it beforehand, because it takes a bit of time, because the agentic implementation is a little bit detailed, right? But when you use MCPs, these are not taking that much time, but it took me, as you can see here, 8 minutes. So I had to run it beforehand so that this video doesn't get longer. But here what I have done is, if you see here at the bottom, I have actually connected to my Gmail MCP. So now when I ask this question that I recently purchased some board games, what are those and what was the cost? It actually went through all my emails in details to read what are the things that I have ordered, and it actually fetched everything correctly along with the date. I've seen that, and it has to, because that's where it has gone the information from my email. If I go here, if I start, you can get to see what ChatGPT did. So I need to confirm the available APIs. I'm querying Gmail for board games and etc. So if you see, it is actually going ahead and searching all these things. Now, these questions here, to be very fair, right? So let me start again, is that I need to confirm the available Gmail API. So this is what equal to the MCP client here, who is figuring out, do I actually have an MCP, or do I have access to the tools where I can actually go ahead and create and make some necessary calls to get specific context out of as a response to this question, right? And it actually went ahead and basically created what I wanted. So that is the power of MCP. Now, what I can do here is that if I'm in Outlook, I can actually go and attach Outlook to this, right? I can log into my Outlook or Microsoft account, and it will start reading my Outlooks, right? I don't have to go, or OpenAI doesn't have to go and change the agentic mode's coding to support multiple things. So that's an example. That's an example of it. One more thing to keep in mind is that what are the capabilities of this MCP server? So let's go a little bit deeper into this concept. So the capabilities, if I look at it, it basically provides two needs to an LLM. Or maybe because we are all talking about agents, I just showed you an agentic example. Let's say agents. So it addresses two different needs of agents. One is providing context, and second is providing tools to do certain things. I don't know what. It depends on what agents you're building. And that is done via the MCP servers here. So now these MCP servers basically advertises mainly three different primitives. Now what are those primitives? Your first primitive is tools with its name, capabilities, input output schema, and everything. So these helps the agent to take actions or take the benefit of other service APIs to basically get more context or do some actions, which can also be a post call, not just a get call. The second primitive is resources, where it can help the agent to get access to something like a database schema, some text file, internal text file, etc. And these are usually the read-only data items that it needs to basically gather more and more context. And the third primitive is prompt template. These are the predefined templates that which suggest some prompts. So you can actually create these prompt templates beforehand for LLMs to basically refer to. And in most of the cases, it is not necessary that every MCP server that you create has to have all these three primitives. And that is why I have made it orange, that most of the time it is the tools, because this is the real power of MCPs that you get to see. And these tools are basically becomes the eyes or hands or nose or tongue of an application with LLMs as a brain that you are trying to build, right? And things to keep in mind, this line, it can query on runtime, right? I'll go a little bit deeper into this. But at this stage, a question should come to your mind. You have looked at what are MCPs, how they work. You know that these are basically client-server models. The question that you might be thinking is, are APIs and MCPs the same thing? We have been using APIs for a long time, right? It is also a client-server protocol. You have client, you have servers. From client, you can make the HTTP post calls, get calls, update calls to basically get some information and give it to your client at the runtime. And these look similar, right? So are they same? Well, there are some similarities between these two. And first similarity is that these provide the abstraction. So the abstraction is there. The client doesn't have to know underlying what is happening, right? Just like your APIs is the same thing. It's also a client-server model that we have seen. But there are some differences because these are meant, so MCPs are meant for certain purposes. And the purpose-driven difference is that these are built specifically for LLMs. It is specifically to give applications or agents which has an LLM inside access to certain tools, certain context, and etc. Whereas the API is more of a general purpose and we're not designed specifically with AI or LLM in mind, right? The second difference is dynamic self-discovery, and this is very, very important. This is the absolute difference between these two. Think of API. When you have REST API, there are many other ways to call. You have GraphQL and everything, but let's stick to the popular one, which is the REST API. There is no runtime discovery. To give an example, let's say you have a login screen, right? And in that login screen, when you provide the username and password and you click on login button, there's a post call that is going behind the scene. You, as a developer, have to code it out that, okay, /post is something that you have to call to make sure that the authentication and authorizations are taking place. Whereas the MCP, as you have seen in the previous slides, supports a dynamic self-discovery. That the host with the client can ask based on the task that is received by it from the user that, hey server, what capabilities you have. And if I go back to this diagram, this is what is happening. So when you ask a question to this host, it can ask the servers, where the server can again advertise the primitives, that what are the tools that you have, or do you have a tool for this purpose? I need to do this. I need to get the weather. Do you have the weather APIs to basically get the current weather or not, right? And that is the main difference between these two. This enables AI agents to adapt available features, the autonomous thing that we were talking about. This prime difference is going to get that done, right? And there is a standardization of interface, right? So every MCP server, regardless what it is built for, it supports build once, integrate many, right? So when you build a host, you can integrate many MCP servers to it. Whereas in case of APIs, if there is a book API for a library and there is a user API, you have to specifically change your client's code or the host's code to basically support that thing, right? So the kicker here is that with all these differences and the similarities that I spoke about, underlying MCPs, when you start writing and when you go to the next modules where you actually build MCPs, you will see that the MCPs are basically wrapper around APIs. So most of the time you will have an API, and through MCPs you are making those APIs understandable to agents. So with this, I think we are end with this module. So we learned about what is context and why did MCP came, what happened before MCP, the function calling. We got an architectural overview of what are MCPs and how they work on a very high level. And then we pondered upon certain things like APIs, because they look similar. Are they the same or not? What are the basic differences? But I hope this module gives you a good startup to ask many more questions to yourself about MCPs, why they exist. Because when we start building our use cases or when we start building our MCPs, it becomes important to understand these whys of MCPs, right? In the next modules, we're going to do some coding. We're going to make some MCP servers. We are going to do some crazy stuff with it. And I will see you soon with the next module.